In the name of Allah, the Compassionate and the Merciful. Hello guys. My name is Salar Delavar Qashqai, and in this video we're going to talk about the sensitive analysis in structural engineering with having this example. You see we have in this example we have one column with 6 degrees of freedom and mass at the top and seismic acceleration at the bottom of this column, and with different properties as sectional properties and material properties, we want to do the nonlinear dynamic analysis and find some parameters. So in this sensitive analysis, we assume that all parameters such as materials properties are the constant value, not the values, and using the different distribution like previous videos which we used Monte Carlo method with different distributions functions. So the materials properties is the constant value, but the rebar area diameters has used the continuous uniform distribution function, and based on this analysis with 20,000 iterations, we want to see the effect of these rebar diameters in our output for PGD, PGA, and PGV of this analysis. So we are going to do 20,000 nonlinear dynamic analysis and then outputting the peak ground acceleration, peak ground displacement, and peak ground velocity, base shear of this analysis, and also the random uniform distributions rebar diameters, and then trying to plot it and finding the best fitted sensitive analysis. So if we run the analysis, at the end you see we have this result. You see we did the analysis with 20,000 nonlinear dynamic analysis and then finding these values, and we are going to plot in histogram. You see that the peak ground displacement is shown in here. It is not a normal behavior, and in rebar diameters we use the uniform, so it's like a uniform you see in here. And also let's see the other results. So maximum peak ground velocity, you see the distributions like this. So you see in all the analysis for best fitting analysis, in my opinion, we must use the median value, and also peak ground acceleration. You see it has this shape of histogram, and also the base shear. You see the maximum value it comes to in this. It shows that the this value has the most value of this histogram data, but the median of this value is here. So it shows that the base shear of this kind of analysis, it's not the normal. It has the various data and the various shape. So let's back to the other analysis. You see in here we are going to plot the rebar diameters based on peak ground displacement. You see rebar diameter. So I defined these values to these values with the random numbers, and then pick ground displacement. You see it has this shape, so you can use linear regression or polynomial regression to finding the best fitted regression, and finding the others peak ground displacement, velocity, or acceleration based on rebar diameters for forecasting or predicting the next respected behavior. And also you see in here rebar diameters and peak ground velocity shape. It has this shape. So the y is I use the logarithm base, so it shows the very good fitted behavior of this plotted data. And also the rebar diameters and peak ground acceleration, it has this shape. And you see you can use linear regression for finding the best fitted line and predicting the other values and working on it. And also rebar diameters and base shear, it has this shape, you see. And also correlations between all the output data is going to be shown. You see the correlation, for example, from base shear to rebar diameters, it's equal to this value, and also rebar to rebar equals to 1. So, and you see, based off this analysis, with the using all the sections parameters as a constant except rebar diameters, and also the material properties as a constant value, we can use sensitive analysis based on very complex analysis like this of concrete nonlinear dynamic analysis. So let's back to the opensees file as a TLS file. You see in here we input this value for reading the different probability distribution function. I defined it in here, and you can use with your own and change it. You see I use random numbers functions and others, or normal, triangular distributions functions, beta distributions functions, finding the maximum array and minimum array, and also absolute array, different quantiles, and also calculating the mean and standard deviations, and also linear regression based on this TCL file, and also the Newton-Raphson method for your own calculation, and also writing the data to the text file. This function is going to be used also, this function in this analysis. So you can change your own in this analysis and change it whatever you like. So our increment is 20,000 increment, and all the section values and is the constant value except column rebar size diameter. So this the minimum is this value and the maximum is this value. So based on this minimum and maximum value, we're going to have a 2000 analysis of nonlinear dynamic analysis, and finding the PGA, PGD, and PGV and base shear, and trying to plot it and making a decision based on this kind of sensitive analysis. So you see this minimum and maximum value. If we showing the rebar, you see the minimum and maximum value is going to be shown in here. It is the logarithm base in x direction also. So the shape is going to be shown as a logarithm in x and y data. And also, let's back to the Python opensees file. So you see the mass is defined, that all the parameters going to be calculated, and in here we're going to output the displacement, velocity, acceleration, base shear, and also in here we're going to output the rebar diameters based on of each random numbers, and also using the Northridge acceleration, and at the end, so the iteration is going to be stopped. So if we run with this batch file, and the analysis is going to be started, and then in here you see that after 78 minutes the analysis is going to be stopped. So the duration of this analysis is very long, so your computer must be have a very high efficiency to run it faster. So after running the code, the output comes in here, and you see all the data is outputted in here based on 20,000 iterations of nonlinear dynamic analysis. And then we use these text files to plot it with Python. So we use these input files in Python code, and write some histograms functions, and trying to plot it in here. So in here we input the data with 20,000 files, and trying to find the maximum absolute value of these data based on outputted files, and also plotting the peak ground displacement, peak ground velocity, and also peak ground accelerations, and base shear also, and so on. You see, you can work on it and find the different parameters, and draw the linear regressions, and predicting the next PGA or PGV based on these rebar diameters. You know, in this example, I used minimum and maximum from 9.9 and 18.1 values. So the minimum and maximum value of this rebar diameter, it has very large distance. So you can change it and use, for example, 14.5 until 18.1, for example. So in this analysis, I want to show that the effect of this opensees and to finding these values calculations based on sensitive analysis. So you can change your own with different values. For example, if you want to calculate the best fitted, for example, width of concrete column section, so you can use these random numbers in here. Okay, guys, and you defined this value as a constant value. Okay, guys, so in this video I tried to show you the sensitive analysis of very complex structures with the nonlinear dynamic analysis, and trying to make decisions and finding the result and with using the statistics analysis. So thanks guys. I'd be glad to know about this modeling. Please have a comment and tell me know about this kind of analysis. Bye.